Hello everyone, myself Hena Shah. Today we are going to discuss topics named line integral, work done and circulation. Fine. So let us start with line integrals. Let f bar be a vector field defined at every point of the curve C. If r bar is the position vector, then the line integral of f bar of r bar over the curve C is defined by line integral over C f bar r bar dot d r bar. Now our r bar is the position vector, so I can write it as x I cap plus y j cap plus z k cap, right? So d r bar will be what? Dx I cap plus dy j cap plus dz k cap. So f bar dot dr bar will be equal to f1 I cap plus f2 j cap plus f3 k cap dot dx I cap plus dy j cap plus dz k cap. Now if I take the dot product, we will get line integral over c f1 dx plus f2 dy plus f3 dz. So we just have to put all these values and do simple integration, okay, in order to find line integral. Next, let us study the definition of circulation. If vector field h bar is the velocity of a fluid particle and c is the closed curve, then the line integral over closed curve C f bar dot dr bar represents the circulation of f bar around the curve C. Then we can find the circulation of f bar whenever C is a closed curve. So what is a closed curve? When the endpoints are same. That is when A is equals to B. For example, if I take a circle, it is a closed curve because we don't have more than one endpoint, right? So whenever A is equals to B, then C is a closed curve. For example, circle, right? Then we can find the circulation, right? Okay, so next let us study the definition of work done. If the vector field F bar is the force acting on the particle moving along the arc AB of the curve C, then the line integral over C F bar dot dr bar represents the work done in displacing the particle from point A to point B. In short, work done W is equals to line integral over C F bar dot dr bar. But C is a what? Arc AB, right? So we can take from A to B F bar dot dr bar. So work done is same as what? Line integral. Okay, so now let us study one more topic, that is path independence of line integral. If the vector field f bar is conservative, when we can call the vector field is conservative? Whenever curl of f bar is 0 bar, right? Then the line integral over the curve C from point A to point B is line integral from A to B f bar dot dr bar is equals to phi b minus phi a. So whenever you are given a conservative vector field, right, what you will do, you will find the scalar potential phi. So the work done or the line integral answer will be what? Phi b minus phi a. Thus, the line integral depends only on the start and the end values, so it is independent of path. Hence, for a conservative vector field, the line integral is independent. So now, next, let us study one important note. So, if the vector field f bar is conservative, that is, whenever curl of f bar is equals to 0 bar and C is a closed curve, then we can write A is equals to B in this formula, right? So our answer will be what? 0. So whenever f bar is conservative and C is a closed curve, that is whenever A is equals to B, then our answer of the line integral will be what? 0. Okay. So now work done in a moving particle from point A to B under a conservative force field is what? Phi b minus phi a. In short, we are summarizing the things which we have studied, right? So whenever the field is conservative, work done will be equals to what? Phi b minus phi a. And next, what we have studied, the line integral is independent of path if our curl is 0. So in short, we have studied two things, that whenever f bar is conservative, what curl will be 0, right? Curl of f bar will be 0, and our line integral over c f bar dot dr bar will be what? Path independent, right? So whenever I want to check whether our line integral is path independent, I only have to check curl is 0. And if curl is 0, then our vector field is conservative. So the work done answer will be what? Phi b minus phi a. And if C is a closed curve, right? Then our line integral over C f bar dot r bar will be 0. But when this is 0, whenever f bar is conservative. Okay. So now let us study one theorem. So fundamental theorem of line integrals. You have to remember the statement of this. Let f bar is equals to f1 I cap plus f2 j cap plus f3 k cap be a vector field whose components are continuous throughout an open connected region D in space, then there exists a differential function phi. So this is your scalar potential such that f bar is equals to gradient of phi, that is equals to del phi by del x I cap plus del phi by del y j cap plus del phi by del z k cap if and only if for all points A and B in D, the value of the line integral from A to B f bar dot dr bar is independent of path joining A to B. So what they are saying, f bar is equals to grade phi. When I can write this, if and only if this line integral from A to B is path independent, right? So what we have to check for path independence? Only curl of f bar is equals to 0 bar, or f bar is a conservative vector field. So now let us solve few examples. So here f bar is equals to this. We have to evaluate the line integral where c is the arc of the parabola, y is equals to 2x square from 0, 0 to 1, 2. So firstly let us draw the parabola y is equals to 2x square. So this will open upward. So this is our parabola y is equals to 2x square. This is our point 0, 0, and let us consider this as a1, 2. Now we have to integrate over arc OA, right? We have to find the line integral over this. Okay, so we have to find the line integral over C f bar dot dr bar. Find now our f bar is 3xy I cap minus y square j cap, right? And our dr bar is dx I cap plus dy j cap, okay? And this is over C. Now our y is what? 2x square. Our y is 2x square. So dy will be what? 4x dx. Fine. So let us put these two values in this. So our line integral will be 3x. In place of y, put 2x square. So 2x square. Now dx will come. So into dx. Now minus y square will be what? 4x raised to 4. You have to put this in place of y into what? Dy will come, but our dy will be 4x dx, right? And now everything is converted into x. So now let us put the limits of x from this. It is from 0 to 1. So now simplify this. So it will be 0 to 1, 6x cube minus 16x raised to 5 dx. Okay, so if now I evaluate this integral, it will be 6 into x raised to 4 by 4 from 0 to 1 minus 16 into x raised to 6 by 6 from 0 to 1. Okay, so now your answer will be 6 upon 4 minus 16 upon 6. If I put the limits, only we have to put 1 only. So 3 upon 2 minus 8 upon 3. Now take the LCM, so it will be 9 minus 16 upon 6. We got minus 7 by 6. Now let us solve one more example. So we have to find the circulation of f bar around the closed curve. R bar is equals to costi I cap plus sin t j cap for 0 less or equals to p less or equals to 2 pi. So here your R bar is what? costi I cap plus sin t j cap. Compare this with r bar of t, that is equals to x I cap plus y j cap plus z k cap. From this you can say that your x is cos t, y is what, sin t, and z is 0. Therefore, dx will be what, minus sin t dt, right? Dy will be cos t dt, and dz will be equals to 0. So now circulation for CF bar dot dr bar will be circulation over C x minus y I cap plus y j cap plus z k cap dot dx I cap plus dy j cap plus dz k cap. Now we know z is 0, so integration from, now put the values of x, y and z. Right? So x is what, cos t, minus y is sin t. Now if you do the dot product, what will come, dx, and dx answer is minus sin t dt. Okay. Now next, put your answer of y. So plus y is what, sin t, right? And now dy is cos t dt. Z is 0, so no need to write that. And now everything is coming in t, so we have to put the limits of t which are 0 to 2 pi. Now if I open the bracket, this minus cos t sin t and this plus sin t cos t will get cancelled out. So what will remain, integration from 0 to pi sin square t dt. Now we know that sin square t can be written as 1 minus cos 2t upon 2 dt. Fine. Now just integrate. 1 upon 2 will remain outside. Integration of 1 will be t, and integration of cos will be what, sin 2t upon 2, limits are 0 to 2 pi. Now we just have to put the limits, so 1 upon 2. If I put it 2 pi over here, so 2 pi. Now sin 4 pi will be 0, so we don't have to write that. Now if I put the 0, this will become 0, sin 0 is also 0, so 0. So final answer is what, pi. So this is the answer of the circulation. Okay. So now let us solve one more example. We have to find the work done by the force field F bar along the straight line Ti cap plus Tj cap plus Tk cap, where the limits of T are from 0 to 1. Again compare this R bar of T, that is Ti cap plus Tj cap plus Tk cap, with R bar of T is equals to x I cap plus yj cap plus z k cap. So from this you can say that x is equals to what, t, y is also t, z is also t. Therefore your dx is equals to dy is equals to dz will be what, dt. Right? So now let us find the work done. So formula is integration over C F bar dot dr bar. So that will be integration over 3x square minus 3x I cap plus 3z j cap plus k cap dot dr bar, means dx I cap plus dy j cap plus dz k cap. Let us put all the values. So if I put the values, x is t, y is t, z is t. So it will be 3t square minus 3t. Right? Now plus, here if I put everything over here is dt, right? So I will put whole dt. And limits of t are from 0 to 1. Now if I put at this place, it will be 3t and plus 1. Now this 3t gets cancelled out, so integration for 0 to 1, 3t square plus 1 dt is remaining. If you integrate, it will be 3t cubed by 3 plus t from 0 to 1. These 3 is getting cancelled out. If I put 1, answer will be 2. If I put 0, it will be 0. So final answer of work done is what, 2. Okay, so now let us solve one more example. We have to find the work done by the field F in the moving particle in xy plane from a00 to b11 along the parabola y square is equals to x. So let us draw the parabola y square is equals to x. So it will come in this direction. X is equals to y square. Now your points are from 0, 0. So this is a 0, 0 to b 1, 1. Fine. So this is your R A B along which we have to find our work length. So now important formula is integration over C F bar dot B R bar. Now put the values of F bar and B R bar. So it is x square minus y square plus x I cap minus 2xy plus y j cap, right? Dot D R bar. So it will be dx I cap plus dy j cap. Fine. Now you are given x is equals to y square, therefore dx will be 2y dy. So now let us put these two values in this. So on putting we will get integration. If I put in this x as y square, it will be y raised to 4 minus y square plus y square times dx. Now dx is what? 2y dy. Fine. Now minus. We have 2xy. So in place of x put y square. So it will be 2y cube plus y times d. Right? And your limits now, everything is converted into y. So we have to take the limits of y which is from 0 to 1. So these two are getting cancelled out. So finally what is remaining? Integration from 0 to 1. 2y raised to 5 minus 2y cube minus y times dy. This is what is remaining. Now just integrate, so it will be 2y raised to 6 upon 6 minus 2y raised to 4 upon 4 minus y square by 2 from 0 to 1. Now if I put the limits, our answer will be 2 upon 6 minus 2 upon 4 minus 1 upon 2. No need to put 0 because everything will go to 0. Now if I simplify, it will be 1 upon 3 minus 1 upon 2 minus 1 upon 2. So 1 upon 3 minus 1. So answer will be minus 2 by 3. So this is the answer of the work done. So now let us go to the next example. So if f bar is this, we have to show that it is independent of path and hence we have to find the line integral where C is a path joining 1, minus 2, 1 and 3, 1, 4. Firstly, in order to show that this line integral is path independent, we will find curl of f bar. So formula is I, j, k, del by del x, del by del y, del by del z, f1, f2, f3. Just put the values of f1, f2, f3. They are, this is f1, this is f2, this is f3. So I, j, k, second row as it is. Just put the values of f1, f2, f3. f1 is 2xy plus z, f2 is x square, and f3 is 3xz square. Just solve the determinant. So if I solve from here, it will come 0 minus 0, right? Now minus j. Solve this with respect to x. So answer will be 3z square minus. If I solve this with respect to z, it will be 3z square again plus a cap prime. Solve this with respect to x. So 2x minus solve this with respect to y. So it will be again 2x. So answer is 0 cap plus 0 j cap plus 0 k cap. So 0 bar. Therefore, line integral over CF bar dot dr bar is path independent, right? So now we have to find the scalar potential phi. So what we know that if it is path independent, then f bar is conservative. So what we can write for conservative vector field, f bar is equals to grade phi. So put the value of f bar, it is 2xy plus z cube y cap plus x square j cap plus 3xz square k cap is equals to del phi by del x I cap del phi by del y j cap plus del phi by del z k cap. So from this we can say that del phi by del x is 2xy plus z cube Del phi by del y is x square and del phi by del z is 3xz square. Integrate with respect to x, right? Phi is equals to then what 2 into x square by 2y plus xz cube plus f1 of y comma z. These two will get cancelled out. Similarly, if I integrate this with respect to y, our answer of y will be what x square y plus f2 of x comma z. And lastly, integrate this with respect to z. So phi will be finally 3 into x into what z cube by 3 plus f3 of x comma y. So these three will get cancelled out. Write each term once and write the scalar potential answer phi, that will be x square y plus xz cube plus c. Okay, so this is the answer of the scalar potential. Now we have to find the line integral over c f bar dot dr bar. So it will be equals to phi of b minus phi of a, because our integral is what? Path independent. Now our value of b is what? 314 and value of e is 1 minus 2 1, and the answer x square y plus x z cube plus c. So we just have to put the values of x, y and z. So our x is 3. So 9 into 1. So 9 plus. Now put in this. So now 3 into 4 cube. Right? Minus. Now put these values. Right? So x is 1 and y is minus 2. So answer will be minus 2. Now plus. X is 1, z is 1. So again 1. So now let us simplify this. So this will be 9 plus 3 into 64, and this will be minus 1. So minus minus 1. So plus 1. So 10 plus we will get 192. So final answer is what? 202. Okay, so this is the answer of the line integral. So I hope you have understood throughout the session. Thank you for watching.